Hello everyone, today in this video we'll be discussing the last module of big data, and in this module actually if you see the syllabus we have two chapters. But all the content which is inside the two chapters is not asked in the exams, so I have picked the topics in such a manner that only the questions which are asked in exam I have discussed here, that too with only key points. All the theory things, if you want to know in depth regarding the key points and all, you have to know, refer the notes. This video is just for your remembering and getting to know what they are actually asking in the answer scripts, okay, and what are the things you need to write. Okay, for more information you need to refer the notes, and anyways I'll be explaining what are the things, but the most of the things you have to write in your own words, okay, because it's not possible to remember so many things, okay, and it will become boring also. So there are 14 questions, not actually 14. Some questions are merged, two questions are merged in one question, like that it becomes around 8 questions which are super important from these 5 topics. And total weightage for each of the questions are present here is 8 to 12 marks. So listen carefully. So we'll be starting with each of these topics and discussing the important questions. 2 or 3 questions are there from each of these topics we'll be discussing, and after we get done we'll be putting a tick mark like this. Okay, so let's get started. Before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this. And let's get started. Estimating relationships. Okay, that's the first topic, estimating relationships. Okay, so in this there are totally 3 questions. So what's the first question? Very simple one. You know what is linear and non-linear, right? Linear means like this, non-linear means like this. That's all. In machine learning, explain linear and non-linear relationship with essential graphs. Model question paper question as well as previous year question paper question. So what do you understand by the term linear? Linear means exists a relationship between two variables x and y when a straight line can fit on a graph. Straight line means y is equal to a0 plus a1x. Y is equal to mx plus c. You used to write, right, in maths. That is only the same thing which is present here. Instead of m we have a1 and instead of c we have a0. This is the equation. If you apply this equation, you can form a straight line in a graph. That's called linear relationship. Okay, so this is the key point you need to write. Next is non-linear relationship. In non-linear relationship you have a curve which is not a straight line but a different kind of line. Here it can be used to represent the data points which are not lying in the same line but in a different lines. Okay, that also can be done in equation. Here just you need to have a0 plus a1x. This is for the linear relationship. Along with that you will ask a2x square or x cube, x power 4 and so on. When you do that it will become non-linear. Okay, these two types of the relationships are present in the machine learning. Next you have to next important question is discuss the analysis of variance, ANOVA. Okay, correlation indicators of relationship. These are the two separate questions I have merged into one question because they are related. Okay, so what is ANOVA? Analysis of variances. What do you mean by variances? If there is a chocolate here, if there is an apple here, if there is a car here, these are what variances, right? These are 3 different things. Now you are analyzing how variant they are, whether these two are close, whether these two are close, whether these two are close, or they are not close at all. Then you will be, based on that you will be doing some analysis. That's called analysis of variances. So it is a method which finds whether the fitted results are significant or not. The ANOVA test for disapproving or accepting the null hypothesis. This is the second point. Here we will be using null hypothesis. Okay, and if the null hypothesis is accepted or not accepted, it will anyways provide a alternative hypothesis. Moving on to the third point, it is used when there are multiple test cases involved. Variation may exist between them and within the sample items may exist. This may be done by examining the amount of variation. What we are doing, we are examining the amount of variation, then deciding if the multiple test cases they are a variant or not within each of these samples. Okay, then there is some formula, like it is called f test. By using the f test and e1v divided by e2v formula is there. By using that you can calculate how much variant it is. Next is the correlation. Correlation means how they are related to each other. Okay, so I can directly show you the diagram. This is perfect positive relationship. If one is increasing, another is also increasing. If one is decreasing, another is also decreasing. There is no relationship. When one is increasing or decreasing, it doesn't matter to the other one. It is independent. These 3 types of relationship exist. That calculation we will be doing by using correlation. Correlation means analysis which lets us find association or the absence of relationship between two variables x and y. One of the most common methods. Okay, what is the most common method? The common method for correlation is R square. Okay, R square. It is what? It is a goodness of fit measure. The larger the R square, the better the regression model. Remember this. If R square is more, it will be better. Then correlation indicators of relationship. How do we indicate relation? Means what indicates us that there is a correlation between the relationships. The main thing used here is the Pearson product moment correlation. Okay, by using this we'll be able to calculate the correlation. So correlation between U and V is given by this formula, where R is the coefficient of correlation and the V and U are the instances. There are three other ways to calculate, like constraint Pearson correlation, Spearman rank correlation, and Kendall's G correlation. If you want a differences between these, you have to refer the textbook. Okay, here just I've given the hint. So let's get tick mark for the first one. The topic had 3 questions, which I merged into 2 questions. Okay, so this is done. So just study this much. This will be sufficient for you, because in exam nothing you have asked beyond this one. So let's move on to the second topic, which is regression analysis. Here how many questions we have? 3 questions. This is a very important question. Explain the simple linear regression and contrast it with multiple regression. Regression, what it is, first you need to know that. Then you need to know what is linear regression. Then you need to know what is simple linear regression and multiple linear regression. Here you will be having non-linear regression as well, and you need to know what is regression model. If these 5 concepts you know, you are done with this module 2, topic 2 of module 5. Here what is regressive analysis? Regressive analysis, if you read the definition only, you will slightly get to know. It means estimating relationships between variables. Regression analysis is a set of statistical steps which estimate the relationship among the variables. They estimate the relationship among the variables by using some statistical steps. Okay, that is what is called regressive analysis. I can give an example. If in the previous 5 matches India scored more than 200, and if they ask you about the 5th match, obviously by the previous data you will be analyzing that it will be more than 200 only. That is regressive analysis. You are, by using previous data, you are determining something which is probably which is probable to happen, and that thing is called as regressive analysis. Simple linear regression and multiple linear regression. In simple linear regression, you will be just having one value and one variable. Okay, that's all, and the equation will be as follows. In multiple linear regression, obviously there will be many variables, 2 or more independent factors involved. That's all what you need to explain, and other things what you need to write in the answer, you can refer the notes, but there's the key points you need to remember just this much. Okay, even you can write in your own words what's their big deal in that. Next question, what is K-nearest-neighbor regression analysis? Okay, K-nearest-neighbor, you can understand by the term the nearest neighbors. How many? K means if I tell 3 nearest neighbors, these are the 3 nearest neighbors. Like that you will be analyzing. Okay, by using that technique. First find all the available neighboring target nodes. And then you set the root node to few values, then find out what are its neighbors, and then again check if the neighbors are most close to their roots only or not. If not, we have to change the roots. That's all what is K nearest neighbors. For finding out the distances, we will be using 3 or 4 methods. Before that, you need to know what is prediction methods: simple interpolation, extrapolation, averaging. These are the 3 methods you will be using for prediction. And the equations for finding out the distances are Euclidean distance. Here's the given formula. Manhattan distance, here's the given formula. Minkowski distance and Hamming distance. Okay, this is for the binary values. Hamming distance is for 1 and 0. Okay, don't write it for the actual data. So these are the things which are important in the second topic. Let's have a tick mark at that. Regressive analysis, 3 questions. It's actually not 3 questions. I've compressed it very much. Here, like, what are the questions are present? What is regression analysis? What is the simple linear regression and multiple non-linear regression? And what is the regressive models? How do you predict the probabilities? What is K-nearest-neighbor, as well as the different types of distances used to calculate the K-nearest-neighbor. Each of these are separate questions, 8 to 12 marks. Okay, so make sure you go through them very well. Let's move on to the third question, which is third topic, which is similar item sets. Similar item sets is comprised of 2 topics. I've combined into one, and I've written the most important questions in that. Okay, so let's have a look. There are totally 2 questions in that. The most important question here is the explain Jaccard and cosine similarity of the sets. Jaccard and cosine similarity are just 2 ways of calculating how similar the things are. If I give you item A and I will give you item B, how similar they are, that is determined by Jaccard and cosine similarity in most of the cases. So you need to know the formula. Let A and B be 2 sets. Okay, what are A and B? A and B are 2 sets. Sets, you know, a set of objects or the items. Those are what? A and B. Jaccard similarity coefficient of 2 set measures using the notation in the set theory as shown below. For calculating the similarity in the Jaccard, we need to have the value of the coefficient of Jaccard. Jaccard AB is equal to A intersection B by A union B. Then we'll calculate Jaccard distance. See, very simple. Calculate the coefficient, then calculate the distance. We need to substitute the value of coefficient in the value of in the formula of Jaccard distance to get the Jaccard distance. So here we'll be substituting the Jaccard coefficient value, and 1 minus that value is nothing but the distance. This is the dissimilarity distance. If you just keep this much, that is the similarity. Okay, in the same way we have the cosine similarity as well. Just the dissimilarity also can be measured. Just the value differs here, uv by u square and divided by v square. Okay, vector based cosine similarity will be uv by value of v, value of u minus value of v, the cos inverse of that. Okay, so that's all what is there in the Jaccard and cosine similarity. Next question, we have the a priori algorithm. Super important question. So what is a priori algorithm? By this diagram itself you can understand and write in your own words. Here how many items we have in the one ACD? 3 items, 4 items, 2 items, and 3 items. Now based on these items we will be calculating which is the most frequent item. A, how many times it appeared? 2 times it appeared. B, how many times it appeared? 3 times. C, 3 times. E, 3 times. And there is D just 1 time, so we will eliminate it. We want items which are more than 2 times. Okay, more than or equal to 2 times. So we'll be eliminating D, and we'll be moving forward. Then we'll be doing the combination of this. AB, how many times it appeared together? AC, how many times it appeared together? AE, like that. BC, BE, and CE. After that we'll again have the threshold. We'll eliminate those things which are not frequently means occurring. Based on that we'll be going on until we reach a point where only one item is left. That is the most frequent item set. Like that we will be calculating using the a priori algorithm. Here some information is given. You can keep this as a hints for you. A priori algorithm is used for frequent item set mining. Frequent item set. What is a priori algorithm? Frequently what item is occurring, that we are calculating. And association rule mining. The frequent item set uses candidate generation process. Okay, this is the most important thing. This is the heart of a priori algorithm. For this, some factors are there. Let's have a look at that. A priori algorithm evaluates candidates for association as follows. Here are some of the items. You can go through it, like CKF1 and large item sets. What are these things? I'll be just discussing this is the actual code if you need to write in some language, but I'll be discussing the algorithm here because this is more important. First step is what? Candidate item sets are generated using only large item sets of the previous iterations. By previous iteration we will generate what? Next iterations. The transactions of the database are not considered while generating item sets. Transactions are not considered. Large item sets of the previous iteration is joined with itself to generate all item sets having size higher than 1. Okay, like that we'll be doing whatever the item sets previous were there, we will be joining it with the next items. What I mean is these are the previous item sets, right? We'll be joining it to create the next one. Then we'll be joining these two to create the next one. Like that we'll be keep on going and eliminating the item sets which are higher than what size? Higher than means not eliminating the items which are higher than one size, and which is 1 or less than 1, we'll be eliminating that. Each generated item set do not have a large subset is discarded. The remaining items are the candidate item set. Like that we will keep on going until we get the final set. So we are done with the topic 3. Let's put a tick mark on that. Similar item sets. Just 2 questions you need to know. The next topic is the text and web mining. Okay, text and web mining. What is text? What is web? There are 3 questions. Okay, what is text? What is web? First you tell me that. Text is nothing but ABCD, and web is nothing but the web in which Google is there. Okay. So you are mining this. What does mining means? Mining means if a mountain is there is gold, you will be mining that gold, means you are taking out that gold and using it. Text mining means what? There is a text here and you are mining it and using it. Web mining, in web there is some content, you are mining it and using it. That's all. You are extracting and using it. That's all. So if you remember this much, you can easily write the definition and the key points. What is text mining? Just remember this form definition. Text mining refers to the process of deriving high quality information from the text. That's all. And it includes the following process: extraction of high quality information, discovering and extracting knowledge, revealing patterns and relationships, and understanding the available data which is unstructured in the form of text. This much you need to write 2 points for the first part. Next what you need to write is if they ask you about explain about the process. So what will be the process? The process consists of 5 steps. Text pre-processing. Before you are sending the gold, remember full in the gold story. Okay, you got some gold. Inside that gold there is zinc, aluminum, and magnesium. You cannot send that as such, right? You need to pre-process it. Means you need to clean what are the unwanted things. Then you will be doing feature generation. That means you can relate it with when you got the gold, you will be extracting the relevant features from it. all the features are not selected. That is what is called feature selection. Then after that you have got the relevant features, you'll be doing data mining. Means you'll be seeing what kind of ornaments you can make with gold, and then you'll be analyzing the results. Like this, only 5 phases are there, so I'll be not discussing what are the key points and what are the explanation of that key points. That all you have to write in your own words. So for your information, I can show you the key points. You can quickly go through it. Text cleanup, tokenization, parts of speech, word sense disambiguation, parsing. These are the steps followed in the pre-processing. This you have to write in your own words. Feature generation, bag of words, stemming, removing stop words, vector model space. By using, you will be generating the features, and from that features you will be selecting some relevant features. By using dimensional detection, n-gram evaluation, noise detection and evaluation. You will be using some techniques like unsupervised, supervised, and identifying evolutionary patterns. Then you will be analyzing the results using the complete process, interpolation, visualization, and use the result for improvement. So that's all about the text based mining. And let's move on to the next question, which is explain the naive Bayes analysis and SVM. Naive Bayes analysis and SVM both are the models used for the correlation between the items. So naive Bayes uses a simple probabilistic and statistical classifier. This is the formula you need to remember. P of C given X has occurred is equal to P of X given C has occurred into P of C by P of X. Each of these has its separate word, you can read it. Next we have the SVM, which is the set of supervised learning methods, the presence of a learning data. Basically what happens here is we'll be having the points here, right, and we'll be finding out a line which is most far from each of these points. Like for example, if I draw a line like this will be far from each of the points present here as well as here. So which is that line we can draw? That is called as hyperplane and also called as maximum margin classifier. And the support vectors is that which is nearest to the points. Okay, far from the points is called the maximum margin, and the nearest is called the support vector. By using this, we can classify the item, hence it is called support vector machine. Okay, so some of the applications of SVM are as follows: classification based on the outputs, regression analysis, pattern recognition, outlier detection. Binary classification can be done as follows: just a single line will be sufficient. Next question we have: write a short note on web mining, web content mining, and web usage mining. There is no point in writing the theory for each of these, so I'll be just telling you what it means, and you can write in your own words, because we all use internet from at least 10 years, right? You can easily write from our own words. So the meaning you need to know, that's more important. What is web mining? Web mining means refers to the techniques and algorithms that extract knowledge from the website data available in the form of web documents and the services. Fine, that is what is called web mining, getting data from the web. Now what we have, the web mining is classified into how many categories? 3 categories. Okay, how many categories are there for the web? If you know these 3 categories, easily you can score 8 to 12 marks. Okay, let's have a look at the 3 categories: web content mining, web structure mining, web usage mining. Content mining means what is present in that you are extracting. Like for example, text is present, image, audio, video, list and table. Those things you are extracting means content extraction. What is structure mining? Structure mining means in the structure you can have the hyperlinks or the document structure. When you see the web structure, there will be the tags, right? HTML tags. Each of these tags are the structure. If you are mining about these things, if you are interested in extracting the HTML tags and the links, then you can go with this one. Web usage mining means what? You will be getting to know how many clicks happened in a particular website, where the person has gone, from which website the person has come, how much time he is going, which is the most frequent item he is going to see more, like that. By using the previous data, what he has seen more in the past, based on that, obviously it is more probable that he will be seeing that one in the future as well. So that's all what we will be seeing in the web usage mining. I highly recommend you to go to the notes as well as the textbook if you want more information regarding this. But if you just remember this one, also you can fill it in your own words as well. Just make this diagram, explain each of these: what is text, what is image, what is interlink, intralink. Intralink means inside the web page how many links are connected. Interlink means between different websites. Like that you can write in own words, there is nothing big deal. Okay, so don't worry, you can easily fill the script for these questions, and this is super important question. Okay, so let's move on to the last topic. Before that, what we need to do? Tick mark, right? Tick mark, done. Now the last topic, this also comprises of three topics I've put into one topic: page rank, web and social graphs. So let's have a look what are the questions present in that. There are totally 3 questions present. Let's have a look at what is page rank. Page rank means what? The authority of the page. Means if there's a person present, okay, if that person is getting attention from all the other persons, whether that person is a high authority person or a low authority person, if all the person wants to talk with this person and she is the very famous person, or he or she, okay, mostly in the case it will be she only. okay, so that person will be most relevant one, right? So that is what is called the page rank. Also in the page rank, some pages are there in the website, all the other links are referring to that website itself. So how many websites refer to one website, that is called its page rank. If four pages refer to one page, that is the rank of it. Okay, I don't know if it will be rank 4 or rank 1, but anyways you got the point, right? The more pages referring to one page, that will be having more priority. Okay, so that is what is called page rank, and based on that only it's written. I will be going through it. You will get the key point. Page rank refers to the authority of the page measured in terms of number of times a link is sought after. The applicability of the page rank works on the basis of the in links and the out links. What is in link? There is a page here, 3 in links are there and 2 outlinks are there. You got the point, right? The page has more authority if it has more inner links than outer links. Okay, if more pages are referring to one page, this has more authority. If more pages are referring to one page, this has more authority. Okay, also one more thing, there should be no dead ends. Means if some websites are coming, it has 5 inner links but 0 outer links, although the number of links will be more, but because of it is a dead end, at least one it should be there. If one it is there, its rank will be reduced by 1, but it will be far more better than dead end. Okay, if it is dead end, its rank will be surely decreasing more than 4. It will become 2 or 1 only, because no one likes a web page where there is no contact again to go further. There is no point in that. Again, the person has to start from the beginning and make sure not to go to that site. That's why even if one reduces by adding an outer link, it is better than dead end. The web structure is defined as the nodes and edges. Nodes are the content, edges are the links. Okay, so like that you can have different pages and the different links present in that. The page rank is computed using the formula that involves edges and the nodes. There were complex formulas, you can go through it from the textbook. I have not written here, so you can learn from there itself. So some limitations are there. Search engine relies on meta tags and metadata. Search engine engine themselves may introduce bias. They may introduce bias. Top authority may be a hub or a page on a different page, resulting in an increased rank of authority page. Tropic, drift and content evaluation, mutually reinforcing. Rank may be unstable, as adding additional nodes may have greater influence on the rank changes. So anyways, this is not important, I just added. If you want, you can write this one, because in some cases if you forget what's the answer, you can write the limitations. Okay, this is not a part of the main question. So what is the social network as a graph? Explain social network as a graph is the last question. So what is social network? Social network means the people connected, right? People connected is called the social network. Another question was there regarding the web structure. Web structure, same I discussed above only, right? How is the web structure defined? Like the web graphs and the minings and the nodes and the edges, how the web are related. That is only what you have tried in the web structure as well. In the social network as a graph, you have two types, using centralities and the page rank, using K, core and the neighbor. Okay, so in the social network, as it is made up of the individuals or organizations called as nodes. There will be nodes and they are connected with the other nodes called as means that is interdependency, and the other nodes connection is done by the edges. Just like how we have in the social media, like the people are connected with each other and each of the people is the node and the connection is the edges. Okay, like that here also we'll be having, we have two techniques using centralities and the page rank, K, core and the neighbor. In centralities and the page rank, we have the following concepts. Centralities include degree, closeness, effective closeness and betweenness. Page rank includes vertex, similar to the page rank, like a web graph. Okay, that's just the authority, means how much important it is. Then we have the different kind of concepts here, like for example, for the centralities, what are defined. Degree means the total number of edges linked to that. Closeness means how close they are, means the correlation is more. Effective closeness can also be analyzed. Betweenness means the number of times a vertex exists. Page rank is a metric for importance. Context size means to the connection to many vertices. Indirect context means betweenness. Structure diversity means the social graph has access to diverse subgraphs. By using this method, if you calculate, that is called as social media network topological analysis using centralities and the page rank. You are analyzing the social graph based on these two factors, centralities and the page ranks. Next, we have the K core and the neighboring matrices. K core is a subgraph in a graph of a network structure. It finds K similar objects or entities which are nearest neighbors after computing the similarities. And collaborative filtering for the frequent datasets using the weighted bipartite graph matching, that is what is called the K-Nearest-Neighbours are there. There are the nodes present here and the neighbors are analyzed, and finally the graph is made. Okay, like what is the correlation between them using bipartite graph we are analyzing. So that's all for this video. Make sure to hit the like button, subscribe to the channel for more videos like this, and thank you so much for watching. I'll see you in the next one.